Good morning, everyone. As of now, only 15 students are joined. We'll start in a couple of minutes.
Okay, sir.
Good afternoon, everyone.
Afternoon, sir.
Why? As of now, only 32 students have joined. Okay. Anyways, so we will start our session. So in last class, we discussed about what topics?
Networking devices.
Networking devices, right? What is the difference between switch and router? Switch and router. Your sir is not explained to you what is switch and what is router? Or you are not revising the concepts?
Router routes the data packets to send data to destination, whereas switch filters the data to send the data to destination.
Data link layer, right? Right, good, very good. So yesterday class we completed about what are different types of network topologies and what are network devices. Today we will discuss about what is switching is. First, before we are going to Is my voice is audible to you?
Yes, sir.
Okay.
Yes.
So everything, whatever the topics we are planning to discuss, first question is why? Why switching? Switching is not a switch. Switch is different. Switching is different. Switch is a device. Switching is a concept. Both are not same. I want to clarify this one. Switching is not equal to switch. And next question is why means. For example, for effective data communication data, so among multiple topologies, which one is the best topology for less data loss? For less data loss, which is the best topology? Yeah, my question is clear. Do you understand my question? Last class we discussed about different types of topologies. Among them, which topology gives more robust, which is more robust, which give high percentage of data loss or data gain, not loss, or minimum data loss, minimal data loss.
Sir, is it mesh? Mesh.
Excellent, mesh topology. Okay, I will take a concept related to mesh topology because every device having a dedicated connection, dedicated direct connection with the other device. So in this context, this is link 1, link 2, link 3, link 4, link 5, and link 6. So whether this link 1 is allocated to anybody except D1 and D2?
No, sir.
Because it is dedicated.
Directed.
Okay, anyways, dedicated, whether it is a positive point or negative point, whether it is advantages or disadvantages.
Advantage.
Okay, consider the two possibilities. For example, device 1 have a data 101111, right? Now this data is ready and we have a dedicated link existing between D1 and D2. So then D1 take up all this data and place it here and send it. At how many times? Maybe it will take 0 to 10 seconds. So all the data, all the bits are transmitted. After the transmission of bits, D1 is ideal. Because ideal means D1 doesn't have any additional bits to transmit from D1 to D2. In this particular scenario, can we use this link? Can we utilize this link for other transmission for other devices?
No, sir.
No. So from 10 seconds, from 11 seconds to 30 seconds, this link is ideal. The link between D1 and D2 is ideal. At the 31 second, again D1 having some data, 10111011. So 31 seconds to 40 seconds, it transmits the data, again ideal. So when my thought is, what I am thinking is, as a common sense, we assume that why don't I utilize this ideal time? Why don't I utilize this ideal time? Why don't I utilize this particular link in this ideal time to other communication? Because at a time, we are using only 2 devices utilizing that particular link in particular amount of time, not all devices. From this thought, a new concept arises. That concept name is called what?
Switching.
So in this particular scenario, what I do, forget about topologies. When we move to switching concepts, 0 to 10 seconds only D1, D2 busy. And that is, this entire link is dedicated to D1, D2 up to 10 seconds only. And from 11 seconds to 30 seconds, my link is ideal. Then I disconnect D1 and D2. I connect the same link for D7 and D8. And we start communicating with each other up to 30th second. Switching from combination of D1, D2 to D7, D8 up to 30 seconds. When by 31 second D1 is ready, again I switching from D7, D8 combination to D1, D2 as usual. So in this way, can we improve our performance of the network or not?
Yes.
Can we say that this is the effective utilization of the resources?
Yes, sir.
That's so. Now tell me, are you supporting switching or not?
Switching is good, sir.
Definitely, right? That's why we go with switching. Now read this point. A network is a set of connected devices. How these devices are connected, it is dependent upon the structure or topology, whether it may be a mesh topology, as I explained in the recent example, or maybe star topology, maybe ring topology, whatever it may be. Whenever you have a multiple devices, we have the problem of how to connect them to make one-to-one communication possible. One-to-one communication means, in our previous example, D1 and D2 having dedicated link up to 10 seconds only. In this particular 10 seconds, is there any third-party device to tap this data? Is there any third device? Is there any unintended device to access this particular link? Except D1 and D2?
No, sir.
No, right? After 10 seconds, we switched from D1, D2 combination to some D7, D8 combination up to 11 seconds to 30 seconds. In this 11 to 30 seconds, this entire link is dedicated to these two devices only, but not D1 and D2. That is called one-to-one communication. This is possible by introducing switching concepts. But what is the limitation of topologies? One old solution is to make a point-to-point connection, between each pair of devices. That is called mesh topology. So when make means dedicated, not switching. It's not switching, it is dedicated. Or between a central device and every other device. Central device like hub, it is dedicated link with device 1, dedicated link with device 2, dedicated with device 1 and device 4. These methods, however, are impractical. Just now, I already explained why it is impractical. Just imagine, for 1,000, my organization contains 1,000 devices. I want to implement mesh topology. Whether really we are utilizing these resources efficiently by using mesh topology or structure? How many total links I need for mesh topology? If number of devices are 1,000, how many total links I need to connect them by using mesh topology? N into n minus 1. Of course, right? N into n minus 1. But simplex n into n minus 1 by 2. Many combinations are there. So 1,000 into 999. These many links of installation. These many things: maintenance, purchasing, and testing. And if any problem occurs, again checking. So entire thing is wastage. Yes, sir. For 1,000 devices, establish a dedicated link. This link is ideal most of the time. This link is not utilizing properly. A dedicated link between two devices, and here I am not supporting any switching concept. So this link is fixed, and 24/7 it is not possible to transmit data. When data is available with the D1, then only transmit. Otherwise, keep ideal only. So what is the purpose of why we are putting that entire time ideal? Why don't we utilizing that ideal time? That is the question. You understand my point?
Yes, sir.
Right. So that's why you call it as, however, are impractical and wasteful. What is the next point? The number and length of the links require too much. Yes or no? Infrastructure to be cost efficient, and majority of those links would be ideal most of the time. Just now I explained the point. Now a better solution is switching. A switching network consists of a series of interlinked nodes called switches. A series of interlinked nodes called switches. That means if you go with device A and device B and device C, all are not directly connected, all are connected to a simple switch and E, F, G. So this switch has a capability, it can establish connection between A and E, it establishes a connection between A and F, it establishes a connection between A and G, and B, BF, BG, CE, CF, CG, many combinations, that is switch on, switch off, connected, disconnected, established, terminated, like this way. And here we are not using any dedicated paths. If it is necessary, use it. Once transmission is completed, disconnect it. Right? Flexibility is there. But in case of topologies, there is no flexibility. There is no comfortability also. So switching are devices capable of creating here temporary connections between two or more devices linked to the switch. In a switched network, some of these nodes are connected to the end systems, others are used only for routing. That means if you take D1 is connected to switch 1, is connected to switch 2, is connected to switch 3, is connected to D2. In this case, switch 1 is directly connected to end device, switch 3 is also directly connected to end device, but switch 2 is act as a routing purpose only, routing from D1 set 1 combination to S3 D2 combination. S2 doesn't connect it to any end device. Do you understand this point? Right. Now, this is some example switched network. All these are called switches, 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 switches. This switching can be done either by using a transmission media of connection oriented or connectionless, physical paths or connectionless paths, by using radio waves or by using datagrams, by using packets, we can do that way. So according to those classifications, we have these many networks. Switching networks broadly classified into circuit switched networks. Circuit switched means here we use physical paths. Physical path. So this physical path means circuit switched networks are used in physical layer. Physical layer. And packet switched networks, either it is a datagram or virtual circuit. Virtual circuit are used in data link layer, and datagram networks are used in network layer, and message networks are used in transport layer, and so on. So because how can we represent data at the physical layer? Options: bits, frames, packets.
Bits.
Bits. How can they represent data in data link layer?
Frames.
Frames. A network layer?
Packets.
Packets. That means so there is no common terminology or common switching technique which is comfortable to handling bits, frames, and packets combinedly. For bits, that structure is different. For frames, that structure is different. For packets, that structure is different. According to structure, according to transmission type, according to transmission media, we can divide our switching networks into multiple combinations. So according to physical layer structure, we go with circuit switching networks. According to frames or data link layer structure, we go with virtual circuit networks. According to packets, we go with datagram networks. You understand my point? Or any doubt?
No doubt.
Right. Now, what is circuit switching network? See, a circuit switching network consists of set of switches connected by what? Physical links. Tell me some example of physical links. How in our home, how your mobile, your landline phone is connected? The cable, right? That cable may be coaxial cable. That cable may be twisted pair, maybe optical fiber also. We consider these three are physical links. Physical links. So a connection between two stations is a dedicated path made of one or more links. Of course, you're right. So each connection uses only one dedicated channel on each link. What is the difference between channel and link? Both are same. What is the difference between channel and link?
Channel has multiple links inside.
No, reverse is true.
Okay.
Link is a combination of multiple channels. Channel 1, channel 2, C. Best example, maybe in your homes you have a Tata Sky or Reliance or Dish TV. We call it as a link. Link contains Gemini channel, G channel, and some other Star Movies channel, HBO channel. See, all these are multiple channels. All these are multiple channels are coming from only one link, that is Dish Link, or Tata Sky Link, or Sun Network. Yes or no? So all these channels, that means if you are establishing a link, this link is dividing into multiple channels. Let us see. So each connection uses only one dedicated channel on each link. Each link is normally divided into n channels by using either frequency division multiplexing or time division multiplexing. So what is frequency division multiplexing? For example, my link capacity is 5 Mbps. Then I can divide my link into 5 individual channels. 5 individual channels of each capacity, how much? 1, 2, 3, 4, 5. Each capacity 1 Mbps. 1 Mbps. That means this entire frequency is dividing into 5 channels. At a time, 5 devices. At a time, 5 devices can transmit their own data with the individual by selecting individual channels. Channel 1, channel 2, channel 3, channel 4, channel 5. This is called frequency division multiplexing. Time division means there is no this type of cross-sectioning, allocating this entire 5 Mbps to device 1 up to 10 seconds for transmission of data. Once after 10 seconds, from 10 seconds to 20 seconds, this entire channel capacity is allocated to device 2. After completion of 20 seconds, again 20 to 30, entire capacity is given to D3. Like this way, this is called time division multiplexing. Depending upon the requirement and need, you can go with either time division multiplexing or frequency division multiplexing. So this is one example. And what is this? Any idea? Do you remember this? Multiplexer.
Yes.
Maybe in data communications or digital logical design, you got this concept. Do you remember that?
Yes, sir. Digital logic.
Multiplexer. See here, we have multiple channels coming into switch. The switch take up all the links, and here by using multiplexing, combining all the signals and converting into single line. In this line, again dividing into multiple channels. At the receiver side, again, these single link channels are distributed to individual frequencies according to their channel capacity. Right? Now, basically in circuit switching, to establish a physical path, because everything is a temporary connection, right? Switching means they're going with temporary connection. In case of circuit switched network, first we need to set up phase. Here I take one example that system A is my source device, system M is my destination device. So system A needs to request a connection to M. In my previous example, if you take this example, this is my source device and this is my destination device. Now, is there any dedicated link existing between A and M directly? Is there any dedicated link existing between, direct link existing between A and M?
No, sir.
No. Then now tell me how to reach from A to M. Here we have 4 switches named with 1, 2, 3, and 4. How to reach from A to M? How can I set up a connection between A to M? A reach to switch 1, switch 1 reach to switch 2, switch 2 reach to switch M. One possibility. What is second possibility? A is to switch 1, switch 1 to switch 4, switch 4 to switch 3, and M. Yes or no?
Yes.
Either this way or this way. So in this way, we can set up the connection. Yeah. Set up the connection. So here, in this case, in our example, that must be the accepted by all switches. System A needs to request a connection VM that must be accepted by all the switches as well as by destination device itself. This is called the setup phase. A circuit is reserved on each link. A circuit is reserved on each link. That means a link is dividing into multiple channels, each channel having specific reservations. And the combination of circuits or channels defines the dedicated path. Combination of all these channels is called as a dedicated link. So once you establish the connection like A to switch 1, to switch 4, to switch 3, and to M, now a connection is set up. Once connection is set up, A start transmission of all his data. Maybe it contains all stream data. All bits transmitted through A to one switch, switch 1 to switch 4, switch 4 to switch 3, switch 3 to switch M. That is called data transfer phase. After the dedicated path made, a connected circuit is established, data transfer can take place. So now A sending all his data available with him, all these bytes. Now there is no data available with A. Then A requests that, dear switch, my transmission is completed. Now I don't need this connection. At that time, switch 1 disconnected, switch 3 disconnected. This is not happened in your traditional topologies. Yes or no? Yes or no?
Yes.
Yeah. So once data transmission is completed, we go with connection release phase. So connection release means why we need to do this one? Because if there is no data is available, then what is the point of connecting? Releasing and again allocating these three combinations to some other devices. I can say that in our example, in this example, maybe here we have a device C and here we have a device Z. So first, in case 1, A is having data, some data. Excuse me. A is having some data and it needs to transmit to M. So A set up a phase, first set up a connection to 4 and 4 set up a connection with 1, 4 and 3 and then M. So all the whatever the data A having, that is transmitted to M. That is this as M contains now 1 0 1 1 0 1 1. Now this transmission is completed and we are disconnecting this one. Why we are disconnecting means if you are not disconnected, maybe C wants to try to send data to Z. So C is having 4, C is having 3. Yeah, right. How can we reach from C to Z? You can tell me. How can we reach from C to Z? C to switch 4, switch 4 to switch 1, switch 1 to switch 2, switch 2 to Z. But if this connection is not released, 4 is busy. 1 is also busy. So when these two are busy, how can I utilize these two for the part of transmission from C to Z? Is it possible?
No, sir.
No. That's why switch can provide the connection release phase. So when data transmission between A and M is completed, this connection is released. When it is released, these two are available to C and Z. They start the sending path from C to Z, dedicated path C to Z, up to some time only. Once the data transmission is completed, again terminated, again established. That is the concept of circuit switching. Do you understand this or any doubts?
Understood, sir.
Any doubts?
Understood, sir.
Cool. Thank you. So finally, circuit switcher. In circuit switcher networks are using in physical layer. So how can we represent data in physical layer? Stream of bits, right? Stream of bits. See, circuit switching takes place at the physical layer. So data transferred between the two stations are not packetized. Not packetized means it should be stream of data, physical layer transfer of the signal. What is the primary responsibilities of physical layer? It is converting bits to signals. Again, from signals to bits. So bits doesn't having any starting address and ending address. It is a flow of things. That means when you are connected, when your tap is connected with the pipe, and the pipe inserted into a bucket and tap. So it is like a flow of water. There is no starting packet, there is no ending packet. It is a source, it is a destination. It doesn't need any addressing also, because if you have a packet 1, packet 2, packet 3, if those packets have different directions, then I need to take care about what is the direction of P1, P2, P3. But here we have only one direction. So no need of any addressing also. There is no addressing involved during data transfer. Here we can use frequency division multiplexing. We already explained this point. So in circuit switcher, the resources need to be reserved during the setup phase. The resources remain dedicated for the entire duration. These resources remain dedicated for the entire duration of the data transfer until the tear down phase, until the breakdown phase. Whether it is advantages or disadvantages, this point, the resources remain dedicated for the entire duration of data. No, it's not dedicated for the particular instant of data or for particular time band only. That is dedicated. That means I can say one point. Device 1 and device 2, device 3. We have a link. That link contains channel 1, channel 2, and channel 3. For example, now channel 1 is dedicated to D1, channel 2 is dedicated to D2, channel 3 dedicated to D3. So here I am taking the time off 0 to 60 seconds, 0 to 60 seconds, or 0 to 60 minutes I'll take. In the time of 0 to 60 minutes, from 0 to 10 minutes, D1 have some stream of data 1111001101. So up to 10 minutes, this entire channel 1 contain D1 data. This entire data is reached to its destination. After 10 minutes, from 11 minutes to some 20 minutes or 30 minutes, D1 doesn't have any data. D1 doesn't have any data to transfer. In this particular time, whether this channel 1 is utilized by anybody?
No, sir.
No. So that is the main disadvantage of circuit switching. We will overcome this problem in coming other switching networks. So efficiency. So the circuit switching networks are not as efficient as the other two types of networks, switched networks, because resources are allocated during the entire duration of the connection. The resources are unavailable to other connections. Even if, for example, a dedicated link establishes up to 30 seconds for a particular combination of devices, among those 30 seconds, if source doesn't have data, then it doesn't send it. So if device 1 is not able to sending this data, what is the point of waiting these 30 seconds? Whether these 30 seconds are wasted or utilized? Wasted, right? Wasted. That point we discussed here. Now, so a circuit switched network normally has low efficiency, but the delay in this type of network is minimal. So what is delay?
Time to transfer.
So for in circuit switched networks, we have a 3 phases. First one is setup, second one is data transfer, third one is connection release. Yes or no? So among those 3 things, which one we call as a real delay? In setup phase, are you transferring data? Actual data? No. So we call as a delay. During connection release, are you really transferring data?
No, sir.
No. So in data transmission only, we are using actual data. But let us see what are different types of delays here. See here. In this concept, I want to send a data from A to B by using 2 switches, switch 1 and switch 2. In this case, this is connect phase, this is data transfer phase, and this is disconnect or connection release phase. In this combination, for connecting A, device A, send a sample data to switch. Dear switch 1, are you ideal or not? Are you available or not? If it is available, then A establish a connection to switch 1, and switch 1 try to request switch 2, dear switch 2, are you available or not? If it is available, establish a connection, and switch 2 requesting device B. B is available or not? If B is available, establish a connection. So for this one and for this one and for this one, this entire 3 steps are called setup. Do you understand this? Do you understand this?
Yes, sir.
Yes, sir.
Setup, right? But what is this space here? Whether this space and this space is same?
No,
Here,
sir.
this space and this space is same? Same or not?
No, sir. No,
Why?
sir. Yes, the time passes.
Yes, exactly. For example, here, for example, device A sends a black packet just for say hello. Hello, are you available or not? So for this 1 bit is transmitted at the 0 seconds of time here. So the same bit is for how much time it takes to reach from A to switch 1. It is exactly equal to 0 seconds or more than 0 seconds?
More than 0 seconds.
Maybe 0.5 seconds or maybe 1 second. Now the time required to send the same one, that hello bit from switch 1 to switch 2, it may take 2 seconds. Switch 2 to B, it may be 3 seconds. So when the distance is increases automatically, the length of the time is also increases, right? From 0 to 3. So here it is 0, here it is 1, here it is 2, here it is 3. That's why this much distance. You understand this? That's why this slope occurs. Do you understand this or not?
Yes, sir.
Now, what is this line? What is this line? This line. Anyways.
Written feedback, sir.
Yeah, again, we need to acknowledge it, right? A requesting B and B sends, say, when I say hello, You need to reply back, yes, I am available, please tell me. So that is called acknowledgement. It is also 1 bit. So again, see here, now here the distance is 0. Here the distance is 1. Here the distance is 2. Here the distance is 3. Do you understand my point?
Yes.
Do you understand my point? Hey.
Yes, sir.
Right. Please respond, because I am not a man here to discuss everything here. So the total time, this total time is delay for setup. Delay for setup. The same thing happened to disconnect also. This is also delay. This delay is dividing into multiple parts. That is called, now read this point. The delay caused by the setup is the sum of 4 parts for setup phase. What is this? The propagation time. You need to understand what is propagation time of the source computer request and the request signal transfer time. The propagation time of the acknowledgement from the destination computer and the signal transfer time of the acknowledgement. What is this? What is this propagation time? And what is this signal transfer time? Both are same. Propagation time means to prepare a bit or a stream of bits, to prepare a bit by the device and place into the link. Prepare the bit and place into the time required to prepare data or a bit or a flag bit and place into a particular link. That is called propagation delay. Do you understand this point or not? Very, very important. There will be a lot of questions in GATE about this one. Do you understand this?
Yes.
Now, once I place this particular bit in this particular edge, I place 1 bit. The time required to transmit this 1 bit from this end to this end, this is called transmission time. I mean to say, signal transmission, what we call here, signal transfer time. Signal transfer time. Do you understand this? Device to placing a particular bit from device to link is called propagation time. From one link edge to transmit the same bit from one link edge to other link edge is called transfer time. Do you understand this?
Yes.
Perfect. Perfect. That is happened in forward direction and reverse direction. We prepare an acknowledgement bit and place into this link is called what? Propagation time for the acknowledgement. Yes or no? Propagation time for the acknowledgement. Acknowledgement is nothing but reply. Do you hear me?
Yes.
Do you hear me?
Yes, sir.
See here. Do you hear me? It is my actual message. Do you hear me? I form a English sentences in my mind and place into network. Do you hear me? From this place, from my sitting position to your sitting position, in middle Zoom is there, Zoom link. So do you hear me is a message transmitted. Actually, if you observe that, if I'm taking do you hear me from my point of time at 4 o'clock, it doesn't reach exactly 4 o'clock. It reaches by 0.5 seconds to your destination. There should be a delay because it is called signal transmission time. And you reply with yes, sir. Yes, sir. This yes, sir is prepared by your brain and put into network. From your edge network to my edge network, that is called acknowledgement transmit time. This entire thing is called delay. Do you understand this or not? Do you understand this?
Yes.
Yes, sir.
Right. So the delay due to the data transfer. What is data transfer? The sum of 2 parts, the propagation time and data transfer time, which can be very long. Why? Here, I want to say hello. Hello is only 1 bit. But once we got hi and hello, There is a lot of conversation between parents. There is a lot of conversation. When we used to start our chat for setup, I say hi. I got a reply of hello. Once it is done, in this between actual data transmission. So this size is more or this size is more. Setup size is more or actual data transmission is more.
Actual data.
That's why, see here, I put this much of gap. It is also same thing. It is downslope only, because when I say hi, how are you? Hi, how are you? I deliver that particular message at 5th second, but it will reach to end destination user by 7th second. So you reply that we are fine, sir. That is the same thing. We start with sometime, we start with sometime, this one. So the propagation time and transfer time, which can be very long, delay due to transfer time. And next page. So this is something about, anyways, it will take more time. As of now, we completed circuit switching networks. I hope you understand that what is delay and what is throughput here. And throughput means number of bits transmitted per second from one place to another place. Transmission rate or throughput. And here we have two basic definitions. You can need to look into these things. Transmission delay and propagation delay. Transmission delay is the time needed to push all the packet bits on the transmission link. That means when a device is ready with 10110011, this is actual data. So to place this entire data from computer, from device to the channel, to the link, to place to the link is called transmission delay. So once I place all these 100110011 here, 100110011 here, at the starting of the link, the propagation delay or the transmission time or signal transmission, the propagation delay is the time it takes for one bit to travel from one end of the link to other end of the link. So anyways, transmission delay means we are successfully placing all the bits here, but the first bit is here, right? One. So how much time it will take to transfer this first bit from this edge to this edge? That is called propagation delay. Transmission delay means placing entire available data from device to network link, network starting of the link. Propagation delay means when we place all the data at the starting of the link, among these multiple bits, least significant bit, first bit, that first bit, how much time it will take to transmit from link left edge to right edge or sender edge to receiver edge, that time is called propagation delay. Do you understand this? Do you understand this?
Yes, sir.
Yeah. So
Yes.
this is something about circuit switching networks. And tomorrow we will discuss about what is packet switching networks, what is datagram, what is virtual circuit, what is message switching. And take a break of 5 minutes. It is already 1:50. We will assemble by 2 o'clock to discuss the lab sessions. In lab sessions, I will explain you how in real time how to identify packets, in real time how to identify source address and IP address, and we work on different types of protocols available in application layer, and whether those application layer protocols are secure or not. Through those protocols, when we are entering user ID and passwords, whether how to detect those IDs and passwords, how to grab those passwords, and how third-party users misutilize those passwords, we will see in from 2 o'clock onwards. Take 10 minutes break. We will meet by 2 o'clock. Thank you. See that lab session will be more interest. So take some time, refresh yourself, and put some more concentration for the next couple of just 30 minutes only. I'll explain 30 minutes. Thank you all. Yeah, and back here again. So as of now, any doubts related to that switching concepts? Any doubts? Right. So all of you get back here. Hi. I need some attention here. So in this lab, I will show you one network monitoring tool, open source network monitoring tool. That name is Wireshark. 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 So I'm sharing my screen. I request all the students, after completion of my session, install Wireshark. I will show you how to download it.
Yes.
For Windows 10, 64-bit. In anything, depend upon your network, your system configuration. See here, download Wireshark. See here, there are list of available installers, patches for 64-bit, 32-bit, portable apps. So I go with Windows installer, and there are list of things also there. Many things are there for Linux. We have some standard packages there. For Mac OS, standard packages. Depend upon many things are there. Depend upon an operating system, we need to change one. I believe that most of the people working with Windows go with this one, 64-bit. Once installation is completed, the main purpose of Wireshark is whatever the devices are connected to your Wi-Fi or your LAN connection or whatever the connection. So it is monitoring how all those devices are communicating their data and what type of data they are transmitted, whether it is secure data or not, and what are incoming packets from the internet, and what are the outgoing packets from our system to other devices, whether all those things are done intentionally, intently, or not intently. To work on those things, we're using Wireshark. Are you able to see this one? This is Wireshark symbol. Are you able to see this?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So I open this one. See, it contains a list of many things. So according to this, it contains many network. It is asking about, it's showing what is the active network here. See here, it's showing a healthy sign, right? That means I connected to network through Wi-Fi. So I click on that one. When I click on that one, it starts capturing packets. In how many ways, what are the different types of processes in my system are connected to internet, and to connection from what is the source address and what is the destination address and what type of protocols we are using. See here, use UDP, user datagram protocol. This is one of the TCP/IP protocol, real-time protocol, TLS, transport layer security protocol. Many things are here, and it is a number, that is the packet number, and time, the time required to take up the capture, and source, destination, protocol time, length of the packet, and information. What is the port number and what is the length of the data received? It is capturing continuously. See here, frame 1. Frame 1 means frame, just now we explained, where the data representation and data link layer is frame. That means if you click on frame 1, it is displaying a lot of information. What is encapsulation type, Ethernet, what is arrival time, how much arrival time it will take, what is the date, and the time shift for this packet, and epoch time, receiving time, and the time delta from previous captured frame, previous displayed frame, displaying everything. What is the frame length? 79 bytes. Capture length, it capturing everything, 79 bytes. Frames is marked. All these, so this is a hexadecimal data. It is a binary data representation. Now, it is Internet Protocol version 4 because our system supports IPv4 only. So what is source address here? 134.224.135. What is the destination? 172.19.153.181. And user datagram protocol, what is source port? Which port we are connecting? UDP means a protocol. A protocol is established between two ports, source port and destination port, internet service provider and device port. What is the device port here? 8801. What is the destination port here? 59268. And what is actual data for hello packet? This is the actual packet. So when I stop here, so when I click on this red button, it stops capturing. See, the flow is stopped. That means it capturing some of data. When so if I click on this one again, blue button, again it start capturing. Red button, stop capturing. So once we stop capture, we take a look of it, how many packets it is accepted. In a single, in a couple of minutes, your wires are capturing these many packets. These many packets. Now, what is the suitable command to find the network address or the IP address of our system?
ipconfig.
ipconfig, right? See here, I am typing ipconfig here. ipconfig. What is my address? 172.19.153.181. See here. What is source and what is destination? It is destination. That means it is acknowledgement. If you see here, source and destination, source. So I want to know what is the source is. I want to know what is the source is. Copy. Value. So NS lookup. What is that address name? 134.224.135.183. Server unknown. Timed out 2 seconds. Request unknown timed out. We don't know what is server is. For example, if you type google.com, see here, server is unknown. See google.com, non-authorized. It's showing this part. For example, if you want to type this address 216.58.200.142, what is this address? It is something address, right? 192 address. So it is my source address, and it is showing some through this one we are connected to network. So here, what is the header checksum? Header checksum. What is mean by validation disabled? Header checksum status unverified. What does it mean?
Checksum is related to error detection and
Perfect, perfect. So disabled means UDP means whether it is connection oriented or connectionless. I will explain this thing. Don't worry. Basically, we have two types of protocols.
Connectionless.
Yeah, I'll tell. So we have two things: TCP, UDP. This is connection oriented. Here we apply error correction methods. It is enabled, but here error correction not enabled, disabled. UDP doesn't care about error correction detection, but TCP will take care about it. That's why user datagram protocol doesn't verify anything. You can read any textbooks. That's why it's showing what? Validation disabled. Header checksum. Header contains that header and trailer part contains error detection correction method code, but UDP doesn't support it. So that's why it is disabled state. And protocol type is this one. Like this way, we are getting so much of information. And this is source address, this is destination address. And one more thing. For example, in application layer, we discussed about some protocols. If you take FTP, FTP is a file transmission protocol. It is used to send data from one place to another place through IP address. Let us see whether this file transmission protocol is efficient or not, whether it is secure or not. I'm starting again capturing. Are you able to follow me? See, this is the, I'm click on this blue button, start capturing packets. I don't want to save the previous capture, continue without saving. See, capturing. Now I open command prompt. I connected to FTP and I want to connect some online FTP portal if it is available. I already downloaded some of the bookmarked some of the FTP portals. For example, I go with this one. Maybe this is my FTP. I take this site and go to the prompt. And I want to connect. O means open connection. And this one. And try to connecting. See connected. And what is the username here? DLP user. DLP user. Here you need to observe one thing. Whatever the things I am typing on my device, automatically this device is connected to Wi-Fi network. In that Wi-Fi network, I installed Wireshark. Wireshark capturing all the packets which are transmitted, which are utilizing this particular Wi-Fi network. So whatever things I am typing, this is also captured by Wireshark in background because I enabled start capture in background. So password, I enter anything. For example, I use some password. Enter. It is not shown here, but I entered anyway. Whether it is correct or not, I entered some password. Anyways, it is correct or incorrect. Now we go to that particular capturing packets and I disabled it. Now are you able to see this address bar? Address bar, filter bar. Type FTP because we want to demonstrate on FTP. I want to press FTP. See all these packets. So 35.163.228.146. For example, where is that? If I take this site ftpdlptest.com, I go to command prompt and here ns lookup. I want this IP address. What is this address? 35.163.228.146. The same or not? See, 35.163.228.146. Whether this address is same or not?
Same, sir.
Yeah, that means we connected to ftp.dlptest.com. The equivalent IP address is this one. So Wireshark capturing that IP address. And 172.19.153.81, this is our address. Right? Now, if you look at here, are you able to see this user? And are you see this password? I typed this password, Singham 199874. Are you able to see this?
Yes, sir.
So please specify the password. It entering. So it's showing username at the same time password. And at the same time, login is correct or not. Login is incorrect. That means in this way we can conclude that whether file transmission protocol is safe protocol, whether FTP is safe, transfer data, whether FTP is safe for transmission of your data. No, see, some people said that FTP is safe. FTP is not built on the secure. It is generally considered to be an insecure protocol because it relies on clear text usernames and passwords for authentication. See here. That is, the data is not encrypted while transmission. While transmission, it sends the actual data. It is not encrypted. That's why FTP was failed. Next, we go with the SFTP, secure file. So see here, how secure is file transmission protocol. There we migrated them. Those people identify that is a wrong protocol or a bad protocol. They migrated to SFTP. In this way, Wireshark can be useful to capture multiple packets, to identify the source IP address, destination IP address, and what protocol they're using, how much data we are transmitting, and information. Information bar, it shows what type of encoding technique we are using. Do you understand this? Do you understand this?
Yes.
In the same way, I go with SFTP now. I mean, I have a other protocol, Telnet. Again, I start capturing the packets, click on blue button, continue without saving. So start capturing all the packets and I move to background. This time I enter some Telnet, and I bookmark some of the Telnet programs also here, predefined. I go with some existing Telnet things, list of servers. And I go with so for example, here we have a one thing is there, that IP address. So I enter telehack.copy, and for every service there should be a port number. For Telnet by default port number is 23. Now I try to connect it. See here, I connect to IP address, I connect to Telnet server from my system to my voice is audible to you?
Yes, sir.
Right. So it contains a list of services. We connected from this place to that Telnet server. If you observe here some new user in this list of comments. In this list of comments,
Users is there.
Users, okay.
Let's see. The fourth row, second last.
Nodes, primes, Zedro, Zork, man. For example, I'm showing that factor, privacy, unit, super, callbacks, job, phone, weather cal, date, finger. For example, I want execute date. Executing date, okay. And
Sir, login.
Login means we should have a ready users, predefined user. We already existed. So again, I do one thing. I quit and I connect again. I connect it again. See here. Now you are seeing new user, right? Are you able to see this one, new user?
Yes, sir.
Now I click on new user. In background, that Wireshark is working. It capturing everything what I'm typing here. New user. So okay, yes. Some terms and conditions. Yeah, okay. All these are. So here, username is, for example, section DS. Password is, I don't tell any password, but you try to tell me what is the password is. So can you guess what is the password? Anyways, so I entered some password. Now I go to Wireshark and stop capturing packets, and my protocol name is Telnet, and enter. See here. It contains many things. It also showing what is the source address, what is the destination address. And I click on one of the thing and just follow. All these things are part of TCP/IP stream only, TCP stream. See here, what commands I'm using. And this one, okay. And come to last. And recent packets, Telnet data. This is Telnet data that follow TCP stream. and it's showing something else here. It is also not there. So in this way, we can work upon one by one and try to identify. Or if you click on this one, data, no, it is not available. Some other port. What is the other port? Telnet data. No, it is not available here. It is not available here. Transmission protocol, retrieving header length, Windows. In this way, we need to search one side again, well, step-by-step procedure, and where actual data is transmitted. Usually, those things are available in this Telnet data. If you click on this Telnet data, let us see whether I'm getting any useful information or not. Data. So you see here, we are executing that date. Do you remember that date?
Yes,
We
sir.
execute date command. So here I got date means maybe we go to some downtime. Again, here are some Telnet data. Here I'm executing what? This time I get you so I'm entering some empty data here. Again, go downtime. And again, observing maybe this may be contain something. Let us see this. What is this? Telnet data. Here I'm entering, it is also contains data. So next thing I can search like this way. Again, I go with the follow TCP stream. Let us see whether I'm finding anything. So here it shows in type help for the detailed command list. Type new user to create an account. Okay. I click on new account and connection and quit. So quit means it is also previous thing. Come down. Again, I do one thing. Many things are here, many things. I need to search one again. SCTP, follow TCP stream. Now, yeah, we got some more information here. And come down. See here. What is our data? What is our password? What password I re-entered? Are you able to see this or not?
Yes, sir.
Yeah. So anyways, they are trying to involve in some special characters. It is somewhat in encrypted format, but not that much way. But we can easily decrypt it. We can easily understand it. See here, I am entering actual intelligence. They just stuffed with some stars. Anyways, next time I try with one other combinations. So just imagine the scenario. We all are connected to when we go to some public places, when we go to some airports. Those people usually providing the free Wi-Fi connectivity. We all are very happy with those. We got very free network. But just imagine, we are using such a bad protocols like these FTP or Telnet, and we try to communicate with each other. We are sharing our confidential information, confidential username and passwords into as either in a family network or either in a friends network or whether it's in a peer network. In the such scenario, if you start your work with that Wi-Fi connectivity, then that particular administrator might be installed this type of software in background. Done. Your entire data was lost. It is in the hands of that particular restaurant administrator. They can take up all your data, username and password. They act as you, masquerade. They act as section data science, and they take all the control over from the account, and they are taking they're changing their own username and passwords. They are creating again dummy roll numbers, dummy passwords, and whatever the marks you got, they can share many things, whatnot. So in this way, in this particular in this particular approach, we can take up all these things like this way. Your responsibilities, I request all the students, install Wireshark into your systems, because explaining by me is waste of process. Whatever the things I explain, you just watch it. But keep your hands dirty, install this Wireshark into your laptops, and first read some contents, how to use the Wireshark, and what is the structure of Wireshark, and start install it and start capturing it in background. First, list out what are the secure protocols, what are the unsecure protocols. List out all the things. This is your project. And among those unsecure packets, as of now, I demonstrated what is the insecure packet. For example, I said that file transmission protocol is not secure. There is a proof. Just now I have shown you how can we extract user ID and passwords. In the same way, telnet is also not secure because we have a proof. In the same way, whether HTTP is secure or not. Yes, of course it is not secure, but what is the evidence? What is the proof? You have to show that to me. HTTP is secure or not? SSH secure shell, secure or not? SFTP secure or not? Like this way, I request all the students start your own project, take out at least 5 to 10, at least 10 protocols, 5 unsecured, 5 secure from application layer, and try to demonstrate yourself by using Wireshark. How can we give me the evidence that this protocol is secure? Because see this, see, I'm capturing these packets. These packets contain this data. I try to open the data, but the data is in an encrypted format. For encryption, what type of algorithm they are using? This is your project. This entire lab is dedicated to installation of Wireshark. Take 10 different protocols. Some are secure, some are not secure, and collect all the evidences, all the proofs to support your point whether the protocol is secure or not. If secure, what is the proof? Show me in Wireshark. If it's not secure, what is the proof? Show me in Wireshark. That is your project. Let's start. If any doubts as of now? Any doubts as of now?
No, sir.
No? And we have many videos are there. You can open Google or open book system. You can open YouTube, anything. They will show everything for you. But in 1 hour session or 60-minute session, it is not possible to address that 100 protocols because we have protocols more than human size, our section size. Those many protocols we have. So let's start surfing the internet, collect some protocols, take up all the protocols into our system, install Wireshark, capturing all the packets, and this time open a HTTP site. Start capturing Wireshark, open a HTTP site. For example, I am sharing my screen. So this time what I am doing, I stop this one. I restart the capturing. And this time what I do, I go with HTTP sites. Maybe I take one of the points, maybe this is there. When I open this one, it's showing some points here. I take up maybe anything. I go with my species info. I open this one. So here I try to log in something, login. Maybe some Kranti, some password, enter. Whether it is correct or not, I entered username and password. Let us see. Again, I go to the Wireshark and stop transmission. I type HTTP, something else, and enter. What is this? Whether it is contain anything or not. Let us see. I need to follow that TCP stream. So in this way, so accept type is text only. Text means definitely whatever the data I transferred, it should be in text format only. You definitely get that user ID password in text format only. That is, it is not secure. But how can we take up that particular, in which line or which combination we can get that particular user ID and password? Take a look of it and come up with your own solutions. Prepare a perfect documentation for this one. For 10 protocols, at least 10 protocols by next lab. Let's start. And there also you can mention what type of protocols you are using. As of now, we have shown UDP, user data governance protocol. You have a proof that UDP connectionless service, it doesn't provide any error checking mechanism. That's why they mention unverified. Header checksum, they are not verified any checksum. In TCP, it is a reliable service. They provide some error detection correction method. If so, what type of technique they are using? In Wireshark, it will show. When we are opening Wireshark, it already show what type of technique they are using. So this is some scenarios. Try to address it. By next lab, I'm expecting all that report. Prepare a base report from application layer. What are the possible application layer? Anyways, I will explain in depth about what is TCP, what is UDP in coming classes. It is a practical session. I'm not expecting any theoretical session. What is TCP? What is header format? I don't want all those things. But whatever the contents we are using there, scrap the information and prepare a report along with the evidences. So, any doubts as of now? Shall we start? Shall we start? Yep. Do you hear me or not? Do you hear me or not?
Yes, sir.
Yeah. Start installing Wireshark and grab some information and prepare a report by next week. Thank you. If any doubts, you can post me in chat box.